We're tackling schedule management and the critical path method, a heavily tested topic on your PMP exam. The critical path is the sequence of activities that represents the longest path through a project, which determines the shortest possible project duration. Any delay on this path directly delays the project's completion. To find it, we first need to understand activity sequencing and the 4 types of dependencies. The most common is finish to start, or FS, where one task must finish before the next can begin. Think of it like this. You must finish painting the walls before you can start hanging pictures. Then there's finish to finish, or FF, where a task cannot finish until another task is finished. For example, the system testing must finish before the final user documentation can be finished. Next is start to start, or SS, where one activity cannot start until another activity has started. Imagine you start writing code for a new feature, and once that has begun, you can start writing the test cases for it. The least common and often most confusing is start to finish, or SF, where a successor activity cannot finish until a predecessor has started. A classic example is the new accounting system must start before the old one can be shut down. The exam will focus heavily on FS, so know it inside and out. Now, let's talk about the mechanics. The forward and backward pass. This process is how you calculate the early and late start and finish dates for each activity. The forward pass moves from the start of the project to the end to calculate the early start and early finish dates for each activity. The backward pass starts from the project's end date and moves backward to calculate the late start and late finish dates. The difference between these dates reveals an activity's float, also known as slack. Float is the amount of time an activity can be delayed without delaying the project's finish date. The formula is simple: late finish minus early finish, or late start minus early start. Activities on the critical path will always have zero float. This is a critical concept for the exam. A common exam trap is to present a network diagram with multiple paths and ask you to identify the float of a specific activity. They might include a near-critical path, a path that is very close in duration to the critical path. A small delay on this near-critical path could turn it into the new critical path. Be prepared to calculate the duration of every path in the diagram. The longest one is your critical path. Another trick is wording questions with complex dependencies or introducing leads and lags, which can advance or delay a successor activity. For a memorable shortcut, remember this phrase: forward early, backward late. The difference is the float we calculate. This helps you recall the order of the passes and the purpose of the calculation. Focus on understanding the relationships between tasks, how to calculate float, and the direct impact of delays on the critical path. For free practice questions, AI-powered explanations, and more exam prep tools, visit openexamprep.com. That's openexamprep, all one word, .com.